The following program is video supplemental instruction. VSI is brought to you by the Teaching Center, UF's Learning Support Center, www.teachingcenter.ufl.edu.
This is number 9, Chem 2045's Fall 2009 Exam 1. Number 9 says, use the following information to find the enthalpy of formation of gaseous HCl. Gives us 3 reactions. They're enthalpies of reactions, and then asks us to find the delta HF of HCl. So the enthalpy of formation of HCl is going to be the amount of heat released when we form 1 mole of HCl gas from whatever elements make it up. So hydrogen makes up HCl, and so does Cl, right? But then you gotta ask yourself, how do I find HCl, or how do I find H in nature in their standard states, and how do I find Cl in their standard states in nature? You find H as H2 gas, and then you find Cl as Cl2 gas. Alright? Now, I need to throw in factors of 1/2 here and here so that the reaction balances. Whenever you do a delta H formation, you always have to make sure your product has 1 mole in front of it, and you balance it according to that. If the fractions throw you off, balance it using whole numbers. So we would throw a 2 in here. But then we need to reduce this down to 1, so then just divide everything by half. So then you go 1/2, 1/2, 1. And you still end up with the same result. Alrighty? So ultimately we're trying to make up this equation. We're trying to end up with this equation. How do we end up with this equation? Well, we have to manipulate the 3 equations given to us, and then we'll use Hess's law to do the same operations on the delta H's of these reactions to find the delta H formation for the overall reaction. Okay? It's a very complicated way of saying Hess's law, where you just add stuff up. Alright, so let's find what is rare in this overall equation. Let's find what is like only found once over here. For example, let's look at HCl. I find HCl only here in equation 3. That means that since this is the only source of HCl, I need to flip equation 3 to get HCl to the right of the reaction arrow, because that's how it appears in the overall reaction. So I'm going to write myself a note. I'm going to say, alright, flip equation 3. This negative means, to me, flip. Alright, so I end up with ammonium chloride yields HCl gas plus ammonia gas. Good. Alright, and now let's see. Does Cl2 or H2, do they appear only once in any equation? Out of all the equations? I see that Cl2 only appears once out of all these equations. And here it's to the left of the reaction arrow. But it has a 1 coefficient. I need it to have a half coefficient. So I'm going to take equation 2, I'm going to cut everything in half. So I'm going to write myself a note, take equation 2 and cut it in half, so that this source of Cl2 matches this Cl2. Okay, there I go, I'm going to cut it all in half. I end up with 1/2 N2 gas plus 2 H2 gases plus half Cl2 gas yields 1 ammonium chloride. Right. Real quick, I want to box in everything that only appears once over here. For example, the HCl only came from 1 equation out of all these 3. So did the Cl2. This reminds me that the guys in the boxes better not get canceled off. I can't touch those, because that's the only source from which they come, is from these. Whoops. Why did I do that? So then, what's left? We need to balance out the H2s. Okay, the only equation we haven't used is equation 1. But how do we orient equation 1? We already see that ammonium chlorides cancel, so we don't have to worry about those. But I realize that I need to cancel off an ammonium because ammonia does not appear in our overall equation. So let's take equation 1 and let's kill off the ammonia by flipping this reaction so that ammonia appears to the left of the reaction arrow, since ammonia is to the right of the reaction arrow here. And since there's only 1 here, I need only 1 there. So I've got to cut equation 1 in half. But I also have to flip it. Flip and cut it in half. Let's do that. I end up with ammonia gas yields half an N2 plus 3 halves H2 gas. And now I'll see what cancels. The NH3 cancels NH3. The 1/2 N2 cancels 1/2 N2. And then I have 2 H2s. Yeah, let me write it like this. I have 4 halves H2, because 4 halves is just 2, right? I have 4 halves H2, and then I have 3 halves over here. So overall, I end up with 1/2 in H2, and I also end up with this 1/2 Cl2, which I better not have canceled off, that's why I boxed it. And I also end up with this HCl gas. Good. So now I have the operations, which I'm going to use on these delta H's. So it tells me to take number 3 and then multiply by negative. So I have 176.2. And then I'll take number 2 and cut it in half. So I have minus 314.4, and then take number 1, reverse it, or multiply by negative, and cut it in half. So that's 45.9. Okay, and once you add all those up, the delta H formation for HCl gas is minus 92.3 kilojoules. And that's the delta H formation.
The Teaching Center, UF's Learning Support Center, www.teachingcenter.ufl.edu.